All right, so today we're going to be doing statistics, and statistics is usually in question 7 of the CSEC mathematics paper. So this question here, it says the table below gives the distribution of the heights of 400 female applicants for the police service. Using a horizontal scale of 2 centimeters to represent a height of 5 centimeters on the vertical scale. Anytime we hear vertical scale, that is talking about the y-axis. And then we need 2 centimeters to represent 50 applicants on the horizontal axis. So the horizontal axis, that is always the x-axis. And then it says draw a cumulative frequency curve for the heights. And it gives us in brackets, start your horizontal scale at 150 centimeters. So now we're going to do this question. And so we're going to go to our graph. So let us go to our graph. All right, so now that our graph has appeared, all right, I want you to ignore the numbers right here. We're going to use the scale that they gave us. All right, so let me go on the pen and go back. They said that we're going on the vertical axis 2 centimeters to represent a height of 5 centimeters. And it says start at 150. We start at 150, and that is for our horizontal scale. And remember, we said our horizontal scale is X. Horizontal mean the letter X, vertical mean the letter Y. All right, so now let's go ahead and do this. So we're starting at 150. So right here at the origin, we're just calling that 150. And then every 2 centimeters, 1 centimeter, 2 centimeters is 5 centimeters. So that's 155. This is going to be 160, 165, 170, 175, 180, 185. All right, cool. Let's go back. All right, so we can stop at 185, or maybe you want to stop at 190, because we know that between 180 to 185, that's the highest class interval that we saw, so we can stop at 190. All right, we can stop at 190, definitely. Ignore the numbers that you're seeing. We're using our scale. All right, so just to write our scale that we're using, on the x-axis, we're saying 2 centimeters represents 5 centimeters. And on the y, let's go back for the vertical axis. They said on the y, we're using 2 centimeters to represent 50 applicants. All right, so 2 centimeters to represent 50 applicants. So where there's a 2 here, this should be a 50. This is 50. This is 100. This is 150. Right here is 150. 2 centimeters, this is 200. And we're going to continue. 250, 300, 350, 400. All right, cool. So now that we have that out the way, now we can go ahead and actually start the question. Now, remember what we're doing. We're drawing a cumulative frequency curve. With cumulative frequency curve, you always draw the upper class boundary. You always plot. So I'm just going to write it here. You plot upper class boundary and the cumulative frequency. So the cumulative frequency, this is your y, but then we're going to plot the upper class boundary as our x. So in this case, the upper class boundary for each we know is going to be 155.5, 160.5, 165.5, 170.5, and so forth. Hey! All right, so let's go ahead and plot those now. So 155.5 is the first upper class boundary, And that corresponds to when the cumulative frequency is 10. Let me just change the color, red, change it to red. This is 10 right here. So we're plotting 10 to the upper class boundary of the 155.5. So it's going to be 155.5 to 10. If right here is 50, then here is 25. 10 is going to be in between 25 and so somewhere right here. It's not 100% accurate, but that's okay. That point right here that we put right there. Somewhere right there would be 10 because in between 25 and 0 is 12.5. So it's a little below midway. All right, so that's our point. All right, now we need 65 to 160.5. All right, so we're going to quickly do these now. 65, if this is 50, then we know in between is going to be 75. So 65 is going to be somewhere here. So 160.5. All right, I'm having difficulty with the computer, but that's okay. So somewhere right here would be 160.5 to our 65. All right, let's speed up a little bit now. 170 to 165.5. 165.5, and we go all the way up to 170. So going up to 170, in between is 175, so 170 would be somewhere about here. All right. All right, I'm having difficulty with the, let me. All right. All right, sorry about that. So right there is about 170. All right. All right, now we'll go 170.5, 170.5 to 280. All right, so we're going 280 now. So 280 is 170.5 to 280. This is 250. Right here is 275. So a little above it is 280. All right, a little above it is 280. All right, as you can see, I have difficulties with the computer and marking, but you know, that's okay. 360, 175.5. So 360 on the y-axis, 175.5 on the x. 175.5 to 360. This is 350. And so 360 would be somewhere about here. Somewhere here should be 360. All right. And then we go 180.5 to 390. 390 is closer to 400. So somewhere right here. All right. And then 185.5 to 400. 185.5 to 400, somewhere right here. All right. Now that we have all our points, now we can draw our cumulative frequency curve. And we're going to start from our origin, which is from right here. We draw our cumulative frequency curve. All right, I'll start from this way. All right, that's our cumulative frequency curve. It's not perfect, but it's the best that we can do with the computer here. But this is our cumulative frequency curve. And now the question, now we completed the first part of the question. That will give us 5 marks. But make sure in order to get your 5 marks, you plot the cumulative frequency versus the upper class boundary. So the upper class boundary, that's on your x-axis, your cumulative frequency on your y. And also make sure you put your scale. Want to put our scale, which they gave us to say on the y, 2 centimeter represented 50 centimeter in term on the vertical scale. All right, 2 centimeter to represent 50 applicants. All right, and also label your axis. That's the last thing we needed to do. Label to say that this was applicants. All right, APP for applicants. And for height down here, I put HEIGHT. All right, so you label that and you're fine. All right, now we're on to the easy part of the question now, which is using our cumulative frequency graph to answer the rest of the questions. So now finish the harder part of the question, which is to do the graph. Now to do the easy part, the nice part. It says now, using your graph to estimate the number of applicants whose height are less than 170 centimeters. Now, using your graph. Now, it says using your graph. So please don't go over here and look and say, oh, for persons less than 170, and then what you probably do is say, oh, here's 170, persons less than, and you want to add up these number of applicants. Don't do that. They want you to use a graph. So using your graph, you're going to go and say, here is 170. You're going to draw a dotted line of person's height from 170 going up. So right here is where my graph is 170. So from my graph, all right, from my graph, when I go across, the number of applicants it corresponds to is 275. So this is telling me that 275 persons are shorter than 170. All right, so go in here. The number of persons whose height is less than 170 is 275. That's how you do it using your graph. Now it says find the median height. Now, the median height is how many persons are there in total? There are 400 female police officers. So the median is in the middle, 200. So we want to find the position of the 200th height. So what we're going to do is 400 divided by 2 is 200. We're going to call the 200 Q2, or the position of Q2. So when you go to 200, you're going to draw dotted lines and then go down. When you go down, that height that you get on the x-axis, that is the median height. Now, if this is 165, this is 167.5. My graph is giving me roughly about 166 centimeters. Right here would roughly be about 166. All right, so we can say that the median height is 166 centimeters. That is your answer. Part 3, it says the height that 25% of the applicants are less than. 25% are less than. 25% of 400 is 100. So what you're going to do is go to your graph and look at the 25th position, which is 100 right here. I like to call 25th position the 25th percentile. I like to call that the position of Q1. So this is the 25%. And then we're going to draw dotted lines going across. And then we're going to go down to look at that corresponding number. That corresponding number that we're getting is 162.5. This is 162.5. All right. And so what that means is the height that 25% of the applicants are less than is 162.5 using our graph. Nice. Now it says find the probability that an applicant selected at random has a height that is no more than 162 centimeters. So find the probability that the person is not taller than 162 centimeters. So what we're going to do is go to 162 centimeters, which is right here, and find how many persons are shorter than 162. So drawing dotted lines from 162 going up and going across, going across, going across. All right. Now remember, mine is not so perfect. It's not so perfect. You'll make sure yours is a little bit straighter and better. But for my graph, it is in between 87. This is about midway between the 100 and the 75. So I'll go with this is about 88. So from my graph, it looks like 88 here. So 88 persons are shorter, are 162 centimeters and shorter, 88 persons. So what that means is that the probability that a person's height is no more than 162, so the probability that the person's height is less than or equal to 162 centimeters, we can say that is equal to the number of persons whose height is 162 or less, that is 88 persons, over the total persons of 400. And that would be your answer. All right? And that's how we do this cumulative frequency question. All right, so the whole idea was to use the cumulative frequency graph to go ahead and answer the rest of the questions. Really nice.
Wow!
All right, so this question is taken from June 2012 paper. And here's another cumulative frequency question for you to go ahead and attempt. You can pause the video and attempt it first, and then look at it afterwards, no problem. All right, so as you have paused the video and attempted, you might be laughing at this question now, having done the first one and saying, this is pretty easy, no problem. So now the question says the table below shows the ages to the nearest year of persons who visited the clinic during a particular week. So noticing it's mostly elderly people visiting the clinic, but no problem. Aww. All right, so looking at it, it says copy and complete the table to show the cumulative frequency. All right, so remember cumulative frequency, as the word is, cumulative, adding together. So the 4 and 11 gave us the 15. So now we need to add the 15 and the 20 to get cumulatively together, that's 35. Oh. Then the 35 and the 12 cumulatively, that will give us 47. So that gives us 2 marks. We get 1 mark for each that we did correct today. Really nice. So 35 and 47. Now it says, part B, using a scale of 2 centimeters to represent 10 years on the x-axis and 1 centimeter to represent 5 persons on the y, draw your cumulative frequency. So let's go ahead and of course we're going to plot our graph. All right, now that we have out our graph, to plot our graph, remember we're plotting, it says using a scale of 2 centimeters to 10 years on the x. 2 centimeters to 10 years on the x. All right, and also 1 centimeter to 5 persons on the y. 1 centimeter to 5 persons on the y. So remember that the total amount of persons is 50. All right, so if we're starting with our y-axis, we want to use, what did they say again? 1 centimeter. 1 centimeter for 5 persons. So that means what we're going to do, for 1 centimeter for 5 persons, we're going up 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's how we're doing it on the y, because it said 1 centimeter represents 5 persons. All right, that's what they told us. All right, and on the y-axis, this is the frequency. Frequency FRE, I will use to write frequency. All right. All right, now on the x-axis, what you're gonna do now is they told us what was the x-axis scale again? 2 centimeters to represent 10 years. Now, remember that you're starting from pretty much age 40. All right, you're starting from age 40. All right, so what I'm gonna do is sometimes you like to see some teachers do what they call a break in the x-axis, right? Or what you can do is just call the origin 40, because that's really where we're starting from. And then 2 centimeters represent 10 years. So this is 50, another 2 centimeters, that's 60, another 2 centimeters, that is 70, another 2 centimeters, that is 80, another 2 centimeters, that is 90. Because that's what they said. They said 2 centimeters is supposed to represent 10 years. And that's it. Always remember to put on your your scale. So I'm not gonna write the scale here because it's given in the question, but you should write your scale right here to tell them what your scale is. All right, please tell them your X is so and so, your Y is so and so. But make sure you label your X-axis as years. All right, this is the age in years. All right, now that we did that, now we can construct our cumulative frequency. So going back, plotting the cumulative frequency, we're plotting cumulative frequency versus upper class boundary. Upper class boundary is 49.5, and this is 4. So the Y value is 4, and the cumulative frequency is 4, and the X value, which is years, is 49.5. So 4 to 49.5, that's somewhere here. All right, this is not 100% accurate, but you make sure you plot it accurately on your graph. 15 to 59.5. So I'm going back to my graph, 15 here to 59.5, somewhere there. Then I need 69.5 and 35. So on the Y, 35 to 69.5 here. All right, and then I need 79.5 to 47. 47 is in between 45 and 50, and it's 79.5, somewhere right here. And then I have 50 to 89.5. That's right there. Drawing my cumulative frequency. That's my cumulative frequency right there. All right, so this is my cumulative frequency graph. Once you have your cumulative frequency graph, you know that you're going to use it to answer some questions. So let's see the questions that they're going to ask us now. It says, use your graph to estimate the median age. So to find the median age is really the half age. What do I mean by half age? You're going to look at how many persons there are in total. There are 50 persons in total. So the median age is the height of the 25th person. All right? The height of the 25th person. So what you're going to do is go to your graph and always on the y-axis, divide the number at the top here by 2. 50 divided by 2 is 25. So this you're going to call this the position of the median, and the median we'll call it Q2. Once you get to 25, you're going to draw broken lines from 25 going across. Once you do that, you come down to see what that corresponding X value is. That corresponding X value is giving me, that looks like 2, that's 62. That is 62. So what that means is, going back here, we can say the median age is 62 years old. That's the median age, and that would give you your 2 mark. 62 years old. That's the median age. Now, part 2 says, find the probability that a person who visited the clinic was 75 years or younger. 75 years or younger. So first thing we need to find out, how many persons are aged 75 and younger. This right here is 75. So this is 75. So we're going to draw dotted lines going up and see what the graph gives us. So go across now, vertical lines going across. Now I didn't draw it so perfectly smooth going across. So just looking at it going across, that would be between 45 and 40. I'm going to go with 42. Your graph would be a lot more accurate. That looks about 42. All right. So what that means is that, going back to the question, the probability that the person is 75 years or younger is 42 persons out of the total amount of person, which is 50. And you can write that as 0.84. Or you can say 84%. All right? And that's the amount of, that's the probability of a person being 75 years or younger